Welcome to this explainer. Today, we are completely rethinking our entire future in space. We're not just talking about, planting a flag and leaving a few footprints behind. No, we're exploring how humanity is actually going to survive, build, and genuinely thrive on the moon. We're taking a deep dive into the architecture of the moon miners and how a really fascinating philosophy called lunar architecture is the absolute key to building the great lunar home. Okay, so let's jump right into this with a question that kind of bugs a lot of space enthusiasts. When you picture living in space, what do you actually see? If you're going by classic sci-fi movies or even looking at the International Space Station today, you probably picture us cramping ourselves into these tiny Earth-shipped metallic tubes. You think of exposed wires everywhere, zero privacy, and living inside what is essentially a highly engineered tin can. But the real question is, are we just doomed to live like that permanently on the lunar surface? Well, the sources we're digging into today call this limiting mindset Sardine Can fatalism. It's this fundamentally flawed approach that's rooted in an unwillingness to look beyond Earth-shipped payloads. Think about it. If your entire architectural philosophy is based strictly on what you can physically cram inside the narrow, cylindrical payload fairing of a rocket, well, you inevitably end up with these cramped, hot-wrecking conditions that honestly feel way more like a World War II-era submarine than a brave new frontier settlement. If we want a permanent future up there, we absolutely have to break free from this fatalism. But to design a real home on the moon, we first have to face some pretty terrifying realities about the lunar environment. Our architecture has to protect us from what's called cosmic weather, and this is a brutal combination of 5 intensely hostile elements. We're talking about engineering against wild temperature swings that bounce violently between the 2-week-long day span and night span. We're dealing with constant, unending bombardment by cosmic rays, which gets punctuated by seasonal, super high-intensity solar flare storms. Add to that the raw, unmitigated solar ultraviolet light, and finally, an incessant rain of micrometeorites. Literally, tiny rocks constantly raining down. Now compare that to here on Earth. We've got it pretty good. We live at the bottom of this warm, moist atmospheric ocean that naturally shields us. In fact, our sources describe our atmosphere as a protective cradle blanket. To put that into perspective, if Earth suddenly froze and our entire atmosphere fell to the ground, it would create a blanket of nitrogen and oxygen snow roughly 15 feet thick. The moon, however, it is an utterly exposed, airless vacuum. There is no cradle blanket. So, how do we actually survive there long term? Well, this reveals a totally brilliant, naturally occurring solution. We simply borrow the moon's own blanket. Instead of trying to build these massively heavy, heavily armored pressure vessels on the surface, the safest and most efficient strategy is actually to burrow under a thick layer of pre-pulverized lunar dirt, which we call regolith. By piling just 2 to 5 meters of this regolith over a habitat, we safely and completely replace Earth's missing atmospheric shield. It perfectly blocks the radiation and stops those micrometeorite impacts cold. And the physics at play here are actually fascinating. When you pile 2 to 4 meters of that heavy moon dust on top of a habitat, the immense downward weight of all that dirt exactly balances out the upward push of the habitat's pressurized, breathable air. This means the habitat itself undergoes way less structural stress. Plus, just by digging down a couple of meters, it locks the surrounding ambient temperature into a completely manageable, constant -4 degrees Fahrenheit or -20 degrees Celsius year-round. It is literally the ultimate natural insulation. But here's the catch. We can't just keep shipping empty habitats from Earth forever. Why? Because of one specific number: 1/20th. This is the harsh economic reality of our gravity well. Shipping functionally similar items from the moon to low Earth orbit takes only 1/20th the fuel cost compared to hauling those exact same items out of Earth's massive heavy gravity well. Once you really grasp that math, you realize that true lunar settlement requires a massive, ground-up paradigm shift in how we build. So the crucial takeaway is that we must embrace lunar architecture and ISRU. Now, ISRU stands for In-Situ Resource Utilization. It's basically a design philosophy that prioritizes dirt-cheap, labor-light construction that's extruded directly from local lunar resources, rather than expensively shipped all the way from Earth. It means we stop living in imported tin cans and we finally start living off the land, building our pressure shells using the exact materials that are right beneath our boots. Let's look at one of the absolute best native lunar resources we have: basalt. The dark plains of the moon are incredibly rich in this stuff. By simply melting and casting this locally abundant rock, we can create an astonishing variety of goods. For heavy industry, we can cast indestructible machine bases and railroad ties. Architecturally, we can make incredibly abrasion-resistant spaceport pavers. And domestically, through a really careful annealing process, we can actually create beautiful unglazed Florentine and hex floor tiles and even heavy-duty planters for lunar agriculture. It's remarkably versatile. And applying these native materials completely transforms the abstract idea of ISRU into something incredibly tangible. By using cast basalt bricks and locally produced glass composites, a settlement stops looking like a sterile metallic science lab, and it actually starts looking like a real hometown. We move away from temporary flimsy outposts and towards a visually distinct lunar aesthetic that the pioneers are going to take immense pride in. Now, obviously, before we're building sprawling basalt mansions, early interior designs are going to need to be incredibly clever. We can utilize these hybrid rigid inflatable habitats that expand once they arrive. By grouping all the plumbing, climate control, and electronics into a central works core, the rest of the space can use movable partitions and fold-out, slide-out furnishings. This is a really smart management of volume, because it creates the psychological illusion of generous space, which gives crews that vital elbow room they desperately need to stay sane. But the ultimate climax of LunArchitecture is graduating from those early, cramped modules to expansive, multi-storied great homes. Once our local manufacturing is fully up and running, we can produce these massive 6 by 20 meter modules entirely on site. These great homes are going to feature multiple floors, actual master bedrooms, and built-in garden solariums producing fresh herbs, spices, and fruits. They'll even have enough extra volume to host autonomous rental apartments for travelers or dedicated space for a family's startup cottage industry. I mean, this is exactly how you foster a permanent, thriving lunar economy. All of this points to a really profound philosophical shift. The source author, Peter Koch, actually notes that over time, a gray party will arise among the settlers. And he's not talking about politics here. It's about a deep, fundamental human desire to connect with our adopted world. Building with the moon, using its regolith for our blankets and its basalt for our floors, rather than just perching imported metal cans on top of it, pays respect to our new home. It fulfills this intrinsic desire to belong to the moon and to truly be her children. So as we wrap up this explainer, I want you to ponder this. We've seen the hostile realities of cosmic weather, the completely brilliant physics of the moon dust blanket, and the sheer game-changing potential of LunArchitecture to build thriving great homes. The vision of our future up there is so much grander than cramming into tiny payload fairings. So, are you ready to leave the tin can behind and become a true child of the moon?